Alright guys, so today we're going to look at how to balance an equation. I'm going to do some simple examples, I'm going to give you some simple steps, and we'll get into it. So let's go. Okay, so why do we need to balance an equation? Here we have a very simple reaction that we've often done, we've all done, and that's the electrolysis of water. Now the electrolysis of water is very straightforward. It is the applying of electric current to water to split the molecule into two separate molecules of hydrogen and oxygen. And that's it. Here we go. So here's our water molecule, and that splits into this and this. But there's a problem. This oxygen breaks the law of conservation. Now, if that happens, the universe must end. It's a pretty fundamental law, so we can't go around breaking it, because that could cause some problems. So how do we fix it? First off, just make sure you understand how it breaks it. Here we have two hydrogens and one oxygen. And over here we have two hydrogens, good so far, two oxygens, there's our problem. So let's have a look. Here's the same reaction, we've exploded it out, left some space, you'll see why. So first thing you want to do is you want to write out the reactants and the products. So we've got hydrogen, hydrogen, oxygen, oxygen. We need to make sure that it's balanced, and that means there's the same amount of reactant atoms as there are product atoms. Let's have a look. Okay, so right now we have two hydrogens and one oxygen on the left hand side. And on the right hand side we have two hydrogens, all good, two oxygens, all bad. So, what do? How about if we double this water? Let's just see what happens. If we double the water, we've now got four hydrogens and two oxygens. We've got the oxygens sorted, but our hydrogens are now a problem. But if we just write two out the front there, we're now balanced. Now, what does this actually mean? This means that for every two water molecules, you will get, so every two water molecules that you split, you will get two hydrogen molecules and one oxygen molecule. That's all that really means, which means for this reaction to even occur, you really need two of them at least. Luckily, there is trillions and trillions and trillions of water molecules in a cup of water, so we're all good. Let's have a quick rule. One of the rules with balancing equations is that we need to make sure that the only numbers we change are the coefficients, not subscripts. The numbers at the front, that is a coefficient. This lower number down the bottom, that is a subscript. That cannot change. That changes the ratio of atoms in a molecule. That's bad, but we can chase it out the front and change it out the front and just have more different molecules. Okay, so there's some pretty simple steps. If you know these steps, you're all golden. You can do really hard ones, really simple ones. First, you balance the metals, okay? Then you balance the non-metals except hydrogen and oxygen. Then you balance hydrogen and finally oxygen. And if you do that, it's going to be super easy. So let's have a quick look. Here's our order: metals, non-metals, hydrogen, oxygens. Okay, so here we have the combustion of butanol. Butanol is an alcohol and it burns really well. So with this added to oxygen gives us carbon dioxide and water. But let's check it out. So at the moment you've got four carbons on the left hand side, one carbon on the right hand side. Already the universe is in trouble. We have 10 hydrogens over here, that's a lot, and 2 over here. Okay, and here we have 3 and 3. So that one's all sorted. Oxygen's good, but the problem is, it's like a Rubik's Cube. You can't just have one side solved. You've got to have the whole thing balanced. So let's do our metals first. There are no metals. There are 0 metals. This is like a Jack Johnson song. So let's have a look at our non-metals. We've got our carbons. So let's balance our carbons. We've got 4 carbons over here. We put a 4 at the front. Okay, so only changing the coefficient. And we now have 4 carbons. Our non-metals, except hydrogen and oxygen, are balanced. Unfortunately, it puts our oxygen up to 9. So that's an issue. So let's do our hydrogens. We'll see where we end up. Okay, so we've got 10 over here, 2 over here. That means if we put a 5 at the front there, that gives us 4 oxygens, 10 hydrogens, they're all matching up, and 13 oxygens. But you see here we've got 4 times 2 is 8, and then 5 times 1 is 5, so 5 plus 8, that's 13. Now, let's balance our oxygen. So we'll come over this side, we'll put a 6 there, okay? So if we put a 6 there, that makes that one there 12, so 6 times 2 is 12, plus 1 there, 13. Now our oxygens are balanced. That, my friends, is about as hard as it gets. Alright, that was pretty straightforward. I hope if you have any questions, ask them in the comments below. We'll get back to you as soon as we can. And we'll see you next time.